Welcome to the deep dive. If you want a quick way to get up to speed on what's really moving in artificial intelligence, you're definitely in the right place. Today is November 1st, but we're looking back at the sources published just yesterday, October 31st, 2025. Okay, let's unpack this. Our goal here is always to, distill the key global AI developments. And for yesterday, October 31st, the story is pretty sharp, actually. It looks like the academic side, the research side was kind of quiet. But the economics of actually running AI, that seems to be where the action was, big time. Seems like the main event is a major challenge in the hardware space, all focused on energy and cost.
That's exactly right. Yeah, when we went through the source materials for the 31st, it was striking. No major new research papers catching our eye, no new models hitting benchmarks in a big way, and, policy, governance, pretty quiet across the board, US, Europe, Asia. So the lack of news on the software or the rules side really just throws the spotlight onto the single biggest infrastructure story from yesterday. That's a hardware play, pure and simple, and it's aimed squarely at making AI, well, cheaper to run.
Okay, so let's jump right into that then. Segment C, chips and infrastructure. And the company making waves is Qualcomm. They've announced new AI 200 chips.
Yeah.
From what we're seeing in reports, like Tetravedas, for instance, the headline is basically Qualcomm going after NVIDIA. But not on raw training speed, right? It's about power efficiency and memory for inference.
Precisely. Extreme power efficiency for inference. That's the key distinction.
Yeah, maybe let's quickly break that down. Training versus inference. Training is, well, teaching the AI model, right? Needs huge power bursts, usually GPUs.
Yeah, that's the heavy lifting up front.
But inference, that's the model actually doing its job, answering questions, processing stuff, running 24/7.
Exactly. And that's where, maybe 80, even 90% of the long-term running costs pile up for a company.
Got it. So Qualcomm's angle is to tackle that cost.
Correct. They're basically leveraging their expertise from mobile, making smartphone chips super efficient and scaling that philosophy up, scaling it for data centers, for the network edge. And the really interesting bit here, maybe not the raw compute, but the memory they're pairing with it, they're using low-power DRAM LPDDR, and get this, up to 768 gigabytes.
Whoa, okay. 768 gigabytes. That number jumps out. But LPDDR, why low-power memory in a data center? Don't they usually want the absolute fastest, like HBM?
That's the critical point. Yeah, that's the competitive strategy right there. Traditional high bandwidth memory, HBM, or even GDDR graphics memory, super fast, no question, but they guzzle power, and they tend to be limited in capacity on a single chip, right? You see maybe 80 gig, maybe 128 gig on top-end chips. Great for training, where speed is everything for that short, intense period. But for inference, running constantly, that memory system's power draw becomes a huge, huge part of your operating expense. LPDDR is designed from the ground up to just sip power. So it dramatically cuts down the energy needed, the heat generated, and having that much capacity, 768 GeV, means you can potentially load these enormous language models entirely onto one chip. Less data shuffling, lower running costs. It's really an attack on the energy bill.
But hang on, isn't there a catch? If it's low power, doesn't that mean it's slower? Are they sacrificing speed, latency, just to save electricity? Seems like a hard sell if you need really fast responses.
That's definitely the trade-off they're betting on. It's a calculated risk. Yes, LPDDR isn't going to match the peak bandwidth of the latest HBM, sure, but for a lot of real-world inference tasks, maybe not the absolute bleeding edge, but things like, processing structured data, running slightly older but still massive models. Often the real bottleneck isn't just the compute speed, it's fitting the whole model in memory or the bandwidth to get data to the chip.
Ah, okay. So if the model fits entirely on the chip because of the huge capacity.
Exactly. You avoid those slower off-chip memory accesses. Qualcomm is wagering that for many, many users, the massive power savings and the ability to keep huge models resident on the chip will outweigh a slight potential increase in raw latency compared to HBM. Think about it. If you can cut your power costs in half for something running 24/7, you might accept a tiny latency difference, especially in distributed systems.
Right, that makes sense. Which brings us to NVIDIA. Their hardware is great, but everyone talks about this CUDA mode. Can you quickly explain, for listeners maybe not deep in development, why CUA makes it so hard to switch?
Sure. CUD is NVIDIA's whole software world for their GPUs. It's the programming framework, the libraries, the tools, everything developers use to make their AI models run fast on NVIDIA hardware. And it's been around for what, over a decade, maybe closer to 15 years now? It's incredibly mature, incredibly sticky.
The developers are just used to it.
Deeply used to it. There's a huge ecosystem, tons of optimized code, tons of developer expertise. So for a company using NVIDIA, switching to Qualcomm or AMD or anyone else, it means potentially rewriting a lot of code, retraining people. That switching cost is significant. It's a real barrier.
Okay.
So Qualcomm's strategy here, focusing so hard on efficiency and the operational cost, the OpEx, is basically trying to make the economic argument so strong that it overcomes the pain of moving away from CADIA. They're essentially saying, look, we'll save you so much money on your power bill month after month. It's worth the effort to switch.
Makes sense. So who's the target audience for that pitch? Where does efficiency first really resonate?
Well, we see a couple of key areas. First, anyone running large distributed networks, think big telecom companies. They might have AI running at thousands of edge locations, base stations. Power adds up incredibly fast across all those sites.
Okay, telecoms.
Second big area, emerging markets, maybe regions like the Middle East, parts of Asia, Latin America, places where they're building out new infrastructure, but power might be less reliable or more expensive. An efficiency-focused chip lets them deploy AI services potentially faster and definitely cheaper than using traditional power-hungry options.
Yeah, that lines up. I saw a quote from Qualcomm's SVP, Durga Malati. He basically said their mobile background gives them an edge in efficient design, and that for inference, memory speed and access are key.
Exactly. It's a strategic pivot, redefining good not just as raw speed, but as efficiency for the long haul, for the actual deployment.
It really does feel like the economic battleground is shifting. Okay, so that's the big hardware story.
Cool.
What about segment policy governance? You mentioned earlier it was quiet.
Yeah, really quiet based on the sources for the 31st. No significant new AI regulations, standards, or major policy announcements coming out of the US, EU, or key Asian hubs.
Interesting. So while the engineers are fighting over watts and gigabytes,
The policymakers were, at least for that day, relatively silent on the AI front.
it kind of underscores where the immediate pressure is, doesn't it? Right now, it's less about navigating new rules and more about managing the sheer cost and complexity of the tech itself.
I think that's a fair assessment for October 31st, yeah. The immediate battle lines are definitely technological and economic.
Okay, let's try and wrap this up then. Stepping back from the details of October 31st. The main takeaway seems clear. The bleeding edge right now is this hardware race, but it's a race focused on power efficiency. Qualcomm's AI 200 launch is sort of Exhibit A, really targeting the operational cost pain points of running AI at scale.
Absolutely. And the aha moment, if you want to call it that, is really this shift in focus. We're past the point where AI progress is only measured by training speed or model size, though those still matter, of course. We're deep in the inference economy now.
Yeah.
So that 768 GB of LPDDR, it's strategically significant because it's a direct assault on the power consumption of running these massive models 24/7. It forces that tough decision and stick with the familiar software ecosystem like CUDAI, or potentially save huge amounts on long-term operating costs by switching.
Right. Now, normally we might mention tools or tutorials here, but it seems none were announced on the 31st specifically.
Correct. Nothing stood out in the sources for that specific date.
Okay, so let's hit the numbers of the day then. What stood out?
First number, 768 gigabytes. That massive LPDDR capacity on the Qualcomm chip. It's not just a big number. It represents that architectural bet on fitting huge models entirely on chip with extreme power efficiency. It signals a different path for enterprise AI hardware.
Got it. 768 gigabytes, and the second number.
Second is really the acronym itself, LPDDR, low power DRAM. It might sound technical, but it's shorthand for this industry's shift in priorities. Moving away from memory solely optimized for peak speed, like HBM, towards memory optimized for continuous, efficient operation. It tells you where the cost focus is moving, efficiency.
LPDDR. Okay, that sets up a final thought for our listeners then. Considering these intense pressures around cost, around energy, how quickly could the metrics we use to judge AI hardware change? Could we see a future where, memory architecture and operational efficiency become the deciding factor for a new AI chip? Maybe even more important than just counting parameters or measuring training speed. Something to think about. Well, that wraps up our deep dive into the AI news stack from October 31st, 2025. Thanks for joining us. We'll be back soon to unpack the next set of developments.